What is the area of this blue wave? This question is very interesting. You will understand why. What do we have? This length here is 8. This is 1/4 of a circle. This is also 1/4 of a circle, and this part here is semicircle. So how do we calculate this area? To calculate this area, we can calculate the area of this quarter circle. Then we calculate the area of this large quarter circle here. And finally we subtract the area of this semicircle. Since we don't know the radii of these objects, let's call the radius a quarter circle r. So if all of this here is worth 8 and this little piece here is worth r, then this other radius here of the larger quarter circle will be worth 8 minus r. And note that this height here is exactly the radius of the large quarter circle. So this will also measure 8 minus r. From here to here is the radius of the small quarter circle that we called r. Since this entire height here is 8 minus rand, this little piece here is worth r. Then this diameter here of our semicircle will be 8 minus r, which will be 8 minus 2r. Okay. We still don't know how much this r is worth. So let's try to calculate this area using letters and see what we can get. So our area will be equal to the area of this quarter circle, which will be pi r square over 4 plus the area of this big quarter circle here, which will be pi 8 minus r square over 4 minus the area of this semicircle, which will be pi 4 minus r square over 2. Note that 4 minus r is the radius of the semicircle, which is half the diameter. We can highlight pi getting this expression. And now let's expand these squares here, getting pi xr square. Quarters plus 64 minus 16r plus r square over 4. Minus 16 minus 8r plus r square over 2. And now I'm going to multiply this fraction here by 2 top and bottom. So I can have 4 in all denominators, then we'll have this expression. And since we now have the same denominator, we can join all the fractions into a single fraction. Just being careful with this minus here, which it will have to multiply here. Here, now look, we have r square plus r square. This will be 2r square. So these 2 to 2r square will be 0, so we can cancel all the squares. Now notice that we have 16r plus 16r, which will also be 0, so we cancel where it appears, and then the only thing that just was 64 to 32, which is 32. So this will give us pi 32 quarters, which is equal to 8 pi, so this is our area. Notice that whatever the value of, they will always cancel each other out, always leaving us with 8 pi. In this example, in the figure I used equals 2. But even if we vary this r to 8 or vary r to 4 or vary r to 0.5 for any of these figures, the blue area will always be 8 pi.